Hey, welcome to another adventure in old code. Today we're going to look at Math 2. I have a great treat for us today because we are joined by my brother Jeff, all the way from very, very, very far away through some magical technical wizardry. Jeff, welcome to Adventures in Old Code. You, sir,
good to be back.
Are famous. This is Math 2. I just earlier this week I'd recorded Math 1 and I haven't even edited it yet, so here we go. That one was on kinematic equations.
Was it yours or mine?
It was mine.
Right. I didn't know physics back then.
It was basically all the different ways you could find all the different variables using all three kinematic equations. Plus F equals ma just for kicks. Anyway, so we are going to take a look at Math 2 here. And let's have a look at what it is. Whoa, Joey's Ultimate Math Program. January 15, 1999. Let's give it a run. Oh my, I almost said oh my der. Wow. Okay, wow. This is a lot of stuff. All right, let's do the equation of the line first. Okay. 5, 6. Point B, 2, 7.
This is some classic grade 10 pre-calculus in action here.
Yep, and I think, well, this was already an episode that I had done months ago. The episode called Equine. It was the equation of a line. So I must have just shoved it into this program. So that's kind of boring, but it gives you your slope and your y-intercept there. Okay. Factor a number.
Factor a number.
What number do we want? What's your favorite number between 1,000 and 2,000?
1,001.
Wait a second. Very nice. I was scared it was going to be prime. Because both 11 and 101 are prime, so surely that pattern must persist. Okay, so those are the factors of 1001. That's kind of cool. The decimal 1/7 as a decimal is 0.143 when rounded to the nearest thousandth, and 7 times 143 is 1001. All right.
Let's carry on here.
Okay, factor a number with the quadratic formula.
Wow.
Whoa.
Oh, I see.
Okay. Oh man. I can barely do that when a is bigger than 1. What? Oh. I gotta make sure b squared minus 4ac is greater than 0. Okay, let's just do...
I guess you hadn't learned about complex numbers yet.
No complex roots. So let's make... How do you do that? You make b really big.
Basically. There you go.
X minus 0.32 and minus 4.679. Okay. For those of our millions of viewers out there who don't know what this is the quadratic formula. What is it?
I can't wait to see that in code.
Yeah, it's going to be awesome. For our listeners, what is the quadratic formula? Go. You're put on the spot.
Let's see. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yes, right on. Okay, And now, now we're
Now
going
we're
to
getting to some
solve a
interesting
two-dimensional linear equation. Whoa. So if 3x plus 8y is 6, give me some other numbers.
2.
And 2x plus
4.
4y equals what?
Wait. If we give it the answer,
We're figuring out x and y.
oh, and
We're
x1 and y1 are different. Oh
Yeah.
my goodness.
The x1 and the y1 are the
One would use like
coefficients.
ax, not x1x.
Yes. What's the answer? 31. Too slow.
Oh, 31, okay.
Whoa. Oh my goodness.
Wow. Can be reduced to the, oh my goodness. Y is now solved. Substitute y in the original equation. X. Huh.
Then that's a point. That is awesome.
That's fairly impressive, actually.
That is clearly supposed to be 81. QBasic does weird things with decimal numbers. And that's supposed to be 56 at the end there.
You could have rounded to the nearest gajillionth.
I think it's just using a single, and when it does floating point arithmetic, it just, yeah. Anyway, okay. Well, you know what? I'm remembering this now because the solve a three-dimensional linear equation is, I remember it being the most intricate, complex program I ever made.
Really?
It's
Well, you need to use a matrix.
Yes, you have to remember this is 1999.
Yeah, I know. That's what I'm.
I was in grade 11. We learned how to
How
solve.
do you manage this?
We learned how to solve a system of three linear equations, basically using, what is it called? I don't even remember. Gauss. Anyway, the point is it's called Gauss something or other when you get to linear algebra in university. We did not learn what a matrix was in grade 11 in pre-calculus. When I went through high school, probably when you went through high school, you only learned matrices in applied.
That would make sense, but we didn't take applied math.
And we didn't take applied math because there was some bizarre thing that said if you're super smart in math, you took pre-cal. If you're a little bit dumber, you take applied. If you're super dumb, you take consumer. That was my understanding.
It's more like pre-calculus was suitable for science, and then applied is suitable for engineering.
Yeah, that's not how it was sort of.
That's my interpretation.
Fast forward a bunch of years later, and when I was doing my co-op teaching blocks, I was teaching high school math, and it was very common for the students who did well in math to take all three, actually.
Wow.
Yeah. Anyway, so let's plug some.
Why didn't I think of that?
Yeah, I know. Okay, let's plug some numbers in here. 3x plus 8y plus 2z equals 9. Give me four numbers.
1.
Whoa! Blew my mind here. 5, 3, 2, and 9. This is how I solved it. We can add the first and second lines and the first and third lines to come up with two new equations.
Oh my goodness.
But when you add the first and second line, you don't add the first line to the second line. You have to add 3 times the second line to the first line, and then negate it so that you get rid of the x's. You have to multiply the second line by -3 and then add the first and second lines.
Yeah.
And that's how you get...
Is that what you're doing here?
That's what I'm doing here, except it looks like I multiplied the first line by -1 and then added 3 times the second one.
Wow. Without using a matrix, that's fairly impressive, actually.
And then from these two equations, we can get to the equation 51z equals -96, basically, which leaves us the value of z to be -1.88, and then we have to keep on going. We now substitute z back into the first equation.
Okay.
Which gives us our y. Substituting y into the first equation gives us x, and then we come up with our point x, y, and z. Yeah. So that is what would that be? The intersection of 3 two-dimensional planes in 3 dimensions, and we found the point at which they all intersect.
Yes.
Whew! I didn't even know that was a thing back then.
That's some second year linear algebra.
Yeah. Perfect. Okay, well, that's it. And then we can quit. Okay.
Oh, that's it.
That's it. So let's have a perusal of this code.
All right.
All right. Joey's Ultimate Math Program, January 15, 1999. I like when I put the dates on here because you can see all the times, it was like in and around here. I was working at Laser Game and I was doing stock simulators, and then I guess I took a break to solve a system of 3 linear equations. Anyway, okay. Factors, equation line, quadratic formula, 2 equation linear equations, 3 equation linear equations.
That's the longest subroutine
ever
in QBasic history. What's this fact array?
You know what? I'll bet that's used for factoring a number. And I'll bet I'm doing it in a bit of a smart way. So anyway, the title screen is just, you have to hit one of those characters. Yeah, whatever. You loop until you hit one of those characters. Based on which character you hit, you go into that subroutine. So let's start with equation of a line. I don't think this is going to be too much mx, y, and b. I learned the equation of the line as y equals mx plus b. You probably had the same teacher for grade 10 as me, didn't you?
Yes, we probably learned basically exactly the same thing.
Yeah, even though we're 3 years apart, we had all the same teacher, same math teacher, same computer science teacher. Anyway, okay, so input point A and point B. And yeah, so we just rearranged y equals mx plus b. Actually, no, this is using... Okay, so we're calculating the slope by taking the rise over the run. The difference of the y's divided by the difference of the x's. Once we have the slope, we can multiply it by our x1, mx plus b. Oh, that's weird. That's weird because I assign it to x, and that I shouldn't have assigned it to x.
In this case, x is just a random...
Just a random variable, except when you're talking about equations of line. That tripped me up. And then b equals y1 minus mx. Okay, so then you print the y, the b. Nice for loop. You give it some values of y. Oh, you feed in values of x, which we call a. Woohoo. And okay, so that's it. That was boring.
And why you wouldn't use x instead of a? It's beyond me.
in 4 loops.
Even I would have used X.
But I already used X up here.
Yes, but you could have reused it.
Yeah, that's true. Okay.
Okay, what's next?
What's next here? Let's have a look. Okay, we've got... Let's go back here. We got factor a number. Let's factor a number.
All right.
All right, let's get to number. Ugh.
Oh, man. That's a long line over there.
Yeah, that's... Ugh. Actually, what is going on?
Your infamous conditional statement.
Okay, so we're looping, and each time through the loop. So let's say I put in 100 there. So each time through the loop, if num divided by a is equal to the integer of a num divided by a, so if a evenly goes, or yeah, divides into num, then what we're going to do, so we found a number that goes into our number, so we're going to add 1 to x, apparently. Fac of x comma 1 is a. And once we know one factor, we automatically know the other factor.
Of course.
Which gets stored in the second of those buckets. So this array, this fact array, is going to be, well, it's 100 elements, right? It's 100.
So we can have 100 factors.
No. Yes. 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 Sorry, I was thinking that we'd use, fac of 3 only if 3 was a factor. No. We only increase x when we found a factor. So yeah, we can only have 100 factors. So you cannot find the factors of 100 factorial. 101 factorial.
That's
okay.
A huge number. I don't even know if QBasic can express that number.
No, it cannot. I guarantee you it cannot. Okay, so we figure out, once we get one factor, we get the other, we store it into the fac array. And we're looping. I don't understand this looping business. Loop until the second factor plus the first factor. What? Is equal to the...
So the first set of factors is equal to the
previous. Okay, so if this was 100, we get the pair 100 and then 1.
Yes.
So added together, that's 101. Then the next thing we would find is 2 and 50. 2 plus 50 is 52. So the first set of factors added equals 101. The second set of factors added equals 52. So this would keep going because they're not equal. The next set of factors,
Would they ever be equal?
They would be equal when the number is a perfect square.
What?
So that's one condition. When they're equal, you've gotten, if your number was 9, you get 1 and 9, that's 10. Then you get 3 and 3, okay, that's 6.
And then you get 9 and 1?
No, let's say your number was 24. You get all the way up to 4 times 6 is 24. Then you try 5. 5 doesn't go into 24. Then you try 6.
Ah.
The reason you stop trying is because 6 plus 4 is equal to 4 plus 6.
Right.
So that's equal, so you've gone past the square root of the number, basically. You've gone past it, and so you don't have to bother checking. But there's a second part. Or And there you go. There's the square check. Or if both factors are the same that you just found.
Right.
Then you can stop checking. Okay, that's not as nice as I thought. Okay. Okay, so if it was a square number and your two factors were the same, then print, what's the difference? Oh, I don't know. If your two factors were the same, then you know you have right. Okay, yeah.
What?
So the reason is, if you entered a square number, then this first if statement would go. And basically, if the number was a square number, you didn't find any unnecessary pairs, so you print them all. If it wasn't a square number, in the case of 24, you have 4 times 6. You figured out 6 times 4, detected that it was unnecessary, so you break out of the loop, but now you have this extra pair hanging around. That's why you only go to x minus 1. I guess I didn't figure out the better way of doing this, which is just to loop from 1 to the square root of the number and check all the primes. Done. Okay.
Hey.
Let's go to quadratic formula. A, B, C, X, and 1. Yeah, the answers. AX plus B squared plus C equals X1. Okay.
This. And G.
This and G. Oh, discriminant! So the discriminant, for those of you who don't know, is the B squared minus 4AC. So what I'm doing here, so we asked for A, B, and C. This is the discriminant. Basically, this has to be greater than 0 in order for you to get two values that make sense from this equation without going into the complex numbers, which I didn't know existed back then. So as long as it's greater or equal to 0, then G equals 1. Oh, G is just a flag. Because here I'm looping until G will be 1 when you've entered valid numbers. So keep asking for input until you've entered a valid input, which means you have a positive discriminant or a non-negative discriminant. And then your discriminant or your dis is the square root of that. I guess, I don't know, is it B squared minus 4AC that's called the discriminant, or is it the square root of that that's called the discriminant?
No, I think it's just the B squared minus 4AC.
It's kind of what I thought. I've assigned the square root of it to dis, though. Oh well. Okay, so now that we have our discriminant, that's the hard part. And then we can just add minus b and divide by 2a, and subtract it and divide by 2a. And we got our two values for x. All right. That's cool. 1 second. This is going to be awesome. Okay. Okay, so that's the quadratic formula.
Now, you don't appear to treat the condition when you only have one root. When x1 and x2 are the same number, it looks like you'd still print.
Oh, yeah, I think so. So let's do one that's a perfect square then. X squared plus 2x plus 1. I think that'll do it, eh?
I can't do that in my head.
What?
Yes, look at that.
Yep. So -1 and -1. That, you're right. That is
An oversight on your
very, very much an oversight because of all the other things that I seem to take into account.
Yeah.
Okay. Now we're going to get into the two-dimensional, the two equation, linear equation. So, so we have all these variables. They're all doubles. I think that's the problem with.
Why are they all doubles?
So you have lots of decimal places. X1, X2, Y1, Y2, answer 1, answer 2, Y, answer. And I set them all to 0.
Interesting.
I didn't have to do that because I'm asking for input for 6 of them. There's no reason to set them all to 0, but okay.
And in previous subroutines, when you ought to have set variables to 0, you didn't.
That's right. Know when to do something and don't do it. That's me. Ay. So what the thing is, what you have to do is you have to take the first equation and add to it a certain multiple of the second equation that will make it 0 in that first column. Oh man, and apparently you do that by multiplying x1 times negative x2.
What? Plus?
Oh, wait a second. No, hold on. X1 is just your coefficient. X.
Yes, you're, wait, this is just 0.
Well, how do you get 0?
That's negative x1, x2 plus x1, x2.
You're right. What?
Now the y makes more sense.
Oh, of course, it's always going to be 0. It's
Okay,
always.
I don't know what you're doing with these
Yeah.
just yet.
I don't know either. I have to go back up here and look at my. So this is x1. I'm looking at the equations here. So if I was to take x1 times negative x2, add.
This is to make the coefficient on x 0.
Yes.
So this x is the coefficient on x.
On x. That's right. Plus
And
x.
of course it's 0 because that was your first step, is to make it 0.
That's right. Okay. And see, but you have to do this.
So the coefficient on x you've named x. Okay.
Yes, I did.
Well, I would have named it Ultra Dumb Guy or something.
I still don't quite understand why I'm multiplying.
Maybe it'll make more sense if we read it on.
Yeah, okay. So y is the same thing except with the y2 times x1. It's like I'm cross multiplying them.
Okay, well, we
Anyway.
don't yet know what you're going to do with those.
No, okay, so answer equals answer 1 times x2 oh dear, plus answer 2 times.
Oh, it's starting to make sense. This is, you're doing the whole matrix thing without really knowing it.
Yeah.
Yeah.
These would have been steps we were taught.
I don't remember learning that.
Well, I did have a different teacher in grade 11 than you.
Yeah.
So the two linear equations, man, I'm going to have to stare at that for a while and figure out. So we're getting our yeah, okay. Yeesh. Can be reduced to, so we've got x, and in this case, x is always 0, and then y, and there's these crazy semicolons to keep everything on the same line, equals our answer. And then our answer equals our answer divided by y. Because it was y equals answer. So answer equals answer divided by y. Y is not solved.
Yes, again, the coefficient of y.
All right. Well, that's fine. Okay. Oh, and then we substituted back by doing this to get x. Okay. Well, yeah. The value of x can then be determined. Therefore, the point is x, comma, answer.
Wait a second.
Because answer was answer divided by y.
Oh no. So the answer is in fact y. Oh my goodness. You must have done this in one sitting, because if you ever
I was very proud of all the
if you
things I
ever
accomplished.
wrote half of it and then tried to come back and continue, you'd be confused. Wow, this is like me level variable naming here.
Hey, I did very poor.
Well, I can't wait to see your 3 equation system.
Oh my goodness.
Yeah, we got to take a look at that.
So now I had too many variables. I had to throw them on 3 different lines, but it looks nicer. Okay, answer 1, answer 2, answer 3, 4, 5, and 6.
6.
The more I look at this word answer, the more it looks like it's spelled funny to me, but it's not. Yeah, okay. I did know about arrays at this point in time, but I decided, no, I just want 6 different variables for each variable. Okay. Set them all to 0. Everything's 0. Here's the form. Ask for the input. And here's where the number...
You have 3 x's, 3 y's, 3 z's. So why do you need 6 of each?
Because from these 3 equations, we're going to make 2 new ones.
Oh my goodness.
Yep.
Okay.
So from the equations,
Okay.
we can add the first and second lines and the first and third lines, whoops, to come up with 2 new equations. So the 4th equation is going to be the first equation times... Why?
You appear to be lying.
Okay, look, if I was going to add the first and second lines, then I would say I would go x1 plus x2 in brackets, right? I'd be x1 plus x2 in brackets. I should be multiplying that by x. Then I'd be adding y1 plus y2 times y. And then I'd be doing the z's. Yes, I do appear to be lying, but I think I did a step in my head.
Yeah.
This becomes answer 1 plus answer 2. But you notice here, I'm using crap, you know what? Then I add the first and third lines. So that's the whole thing, except this is what I was doing, I think. So now I was taking everything here, except this is the first and third lines. I think I did this step in my head, or definitely on a piece of paper, because now I'm going to add them, but now I'm in a situation where I have a system of two equations, just like the two variables in two equations.
Oh.
So then this to so x1, I still don't know
This plus that.
what in the world was going on in my head.
I don't know.
No. Apparently the way you get x4 is to take x1 and multiply it by negative x2 and add x2.
And x4 will always equal 0.
Yes, which is what we want, because we only want y and z left. But y1 minus x2. I remember writing this, and after I wrote it, I was just like so mentally exhausted. I was done. I was done. It was over. I couldn't think anymore. And now looking at it 20 years later, literally 20 years later, 20 and almost 2 months, I can't quite. The problem is I did some steps in my head and I don't know what they are. Ay. That's too bad that we can't figure that out. But once you get to this point, it then degrades into the previous version, where you have a system of two equations with only a y and z variable. Ay. Okay, well, we now substitute z back.
The question I have is, what if the solution of this system is not a point? What if it is in fact a line or even?
Now you get that when one is a multiple of the other, exactly, right?
Well, I mean, the easiest way is if all three equations are the same.
Okay.
Yeah, so this is three planes that are the same.
Yay!
What? Wait, what?
Z is minus 1 point, number sign, ind.
That's some new kind of number I didn't learn.
I think I tried to divide by 0.
That's probable. But it wouldn't...
That's kind of a weird...
You'd get a special error message.
Yeah.
To divide by 0.
What's... Okay. Now...
What's this?
This is a point in some special space that we have yet to discover. Minus 1 point ind. Because
Yes. Instead of imaginary numbers, these are inf numbers.
Inf. Look at that. 7 divided by 0 is 1 point. I guess that's infinity.
Yes, but what's ind?
Oh yeah, it was an ind. Oh, hold on. How do you do I can't remember that. I'll bet I know what it is. Dim num as double. I bet it's because it's a double.
Right, because then it makes it bigger. No, it's still infinite. And remember, it was negative.
Yeah, okay. Maybe it's... Maybe both of them have to be doubles.
Wait, what if it's 0 divided by 0?
0, which it probably would have been.
Yeah.
You're right!
Oh, there we go.
Indeterminate. That's an indeterminate form.
Yeah.
Now I can use L'Hopital's
I don't just
rule.
divide by 0. I divide 0 by 0.
Yeah, that's awesome.
Interesting. I never saw that before in QBasic.
Nope. I'm surprised it hasn't.
I've divided by 0 at times. Usually it cuts out and gives an error message that says division by 0. I've never seen this before.
I wonder if this is a DOSBox thing. There are very subtle differences. So, anyway.
DOSBox, in fact, allows one to divide by 0.
Well, it doesn't give it an actual value. It does, but I guess so. All right, cool. Well, that is, I think, all we're going to get out of that program. This is officially the longest adventure in old code we've ever had. Okay, well, that was super awesome. Thanks for joining us in this adventure in old code. Thanks to Jeff. Hopefully we'll get you back again now that we've got this technological stuff figured out. I have got a whale of a time ahead of me to edit this properly, but we'll see how that works. So thanks for joining us. Have a nice day, and we will see you next time.